Sir, formation of red blood cell is
Mhm. What is required? We did learn about different minerals in the chapter components. Remember?
red blood cell is for sir
Mhm.
iron.
Iron is required. Okay, no, very good. Okay. Your camera is on, but I can't see you. 1 minute. Okay. Further, light travels in what type of line? Is it curved, zigzag, straight, or circular?
Straight, sir.
Okay. Now, for the previous question, as you have answered iron. Okay. You know, in our blood, different components are present. हमारे blood में different cells पाए जाते हैं, different components पाए जाते हैं हमारे blood में, right? Like red blood cell is found in our blood. White blood cells पाए जाते हैं, platelets. So many things are found in the blood. Okay. Now we know कि blood has got different function to perform. Blood को different
Yes.
functions perform करना होता है. Blood contains red blood cells, white blood cells. For example, say that this is the red blood cells. In short, we write this as RBC. The full form of RBC is
Red blood.
red blood cells. Say this is WBC. That is white blood cell. Talking about the function of the blood, we know that one of the function of the blood is to transport oxygen. Right now,
Yes.
the food that we eat, ultimately, when that food is absorbed into the blood, then that food is transported to each and every cell in the body.
Yeah.
So suppose we eat something, and when it is completely digested, so हमारे small intestine से वो food absorb होता है, right?
Yeah.
And it goes into the blood, right? Now?
Yeah.
And blood will be transporting it to each and every cell in the body. You know
Yeah.
about the cell, the fundamental
Yes.
unit of life. We all are made
It
up of
is a,
cells now.
yes.
Mhm. Okay. So cell requires food, but cell requires oxygen also. Oxygen भी cell की जरूरत है. So how does the cell get oxygen? So
By the
blood,
blood.
by the blood, exactly. So in the blood, how the oxygen flows in the blood? So we know कि we have the red blood cell in the blood. हमारे blood में red blood cells है. Now the red blood cells kind of look like this. They kind of
Yeah.
looks like they have kind of a concave shape. You know about the concave lens, remember?
Yeah.
So it has a concave shape, like it is bent inward, kind of like this. Hope you can understand, kind of like this. Further, another important thing is that it has hemoglobin in it. Have you heard of this term, hemoglobin?
Yeah.
Okay. So hemoglobin is mainly responsible for carrying oxygen, meaning that the oxygen which we are inhaling, the oxygen that we're inhaling, it
That is
ultimately
present in the red blood.
that combines with the hemoglobin in the red
Oh.
blood cell. It combines, it attaches itself to the hemoglobin. वो ऑक्सीजन hemoglobin से attach हो जाता है. Getting it now?
Yeah.
So further thing is that the hemoglobin now for the for the proper functioning of the hemoglobin or hemoglobin को build करने के लिए, to build the hemoglobin, iron is important. Getting it now? So that's why iron is important. Like for the formation of red blood cells, iron is important because red blood cell contains hemoglobin and hemoglobin is made up of iron. It requires
Yeah.
iron. That is the thing. Okay. Light travels in what type of line, and what do we call this
Straight.
property? What do we call this
Rectilinear
property?
propagation of light.
Exactly. Okay. What do we call the reflection of light on a smooth surface?
Regular reflection.
By the way, Salman was supposed to be joining. Ayush is also one new student. He was supposed to be joining today. Anyways, so that is regular reflection. Okay. Last
Yeah.
is, which of the following is a transparent material?
Transparent glass.
That is obviously glass. Very good. What happens to light when it passes through a prism?
It reflects.
No, it does not reflect. Say that this is a white light. Okay, na?
Oh, white light.
So it is going to disperse now.
Disperse, yeah.
Remember the case of the prism. When the light ray will be passing through the prism, it will split into its component color.
Oh yeah. Like all the seven colors.
Exactly, it splits into all the 7 color, namely, as you
Violet,
can,
indigo, blue, green, yellow, orange, red.
exactly, no. So there you go. Here as we can see that the white light is passing through a prism. Okay.
Yeah.
And it splits, it kind of disperses. It disperses into red, basically violet, indigo, blue, green, yellow, orange, and red color like this. Getting it now?
Yeah.
So this one here is the violet, indigo,
Um,
blue, orange, and red.
Green, yellow, orange, red.
Exactly. And suppose if you were to obtain this color, obtain the image of these colors on a screen. So उसे हम spectrum कहते हैं. Remember? That is called as a
Yeah.
spectrum. That is the case. Okay. Na? So the light will be splitting here. So that is called as dispersion of light. This phenomena
Yeah.
of splitting of light, splitting of white light into its component color, that is called as dispersion of light. Also, we have the example of the prism. But do we have some examples of natural dispersion of light also? Where the light,
Yeah.
Mhm. Give an
Like
example.
the sun's rays go. The sun's rays like reflect to the mirror or smooth surface.
No, here we are seeing that light ray is splitting in the white ray of light is splitting. Getting it, Halima? The
Yeah.
white light is splitting into 7 colors. I'm asking to give you some natural examples. An example in the nature where we get to see that the white light is splitting. We have the example of a rainbow.
Yeah.
We have the most common example, no? The rainbow, which
Yeah.
is which is a colorful pattern. So that is what. That is also an example of dispersion of light now, where the white
Yeah.
light is splitting into its component color now.
Yes.
So there, what basically happens, during the rainfall now, whenever there's a rainfall, so there are tiny droplets of water in the air like this.
Yeah.
So that tiny droplet of water will be acting like a prism, and as the light ray will be passing through all these droplets of water, so they will be getting splitted. They will get split into the red, orange, yellow,
Hello.
yellow color, and green color, and as follows. Getting it now? Like this.
Yeah.
So that is how rainbows are formed. There also dispersion of light occurs. You understood this or not?
Yes. Yeah.
Okay, no? So that is the case. Okay. Okay. Next question.
What is the primary source of natural light?
Primary here
Natural
means
light. Sun.
primary means main source of natural
Oh.
light. So as you have answered, by the way, it is correct. That is sun. Okay, no?
Yeah.
Isn't sun also a star? Yes,
Yeah. It is a burning.
it is a star. Okay, by the way, you know how many stars are estimated to be in the Milky Way galaxy? The name of our
No.
galaxy is the Milky Way galaxy, no?
Yeah.
You know about there are about 400 billion stars in the Milky Way galaxy, and sun is just like between 100 to 400 billion, I would say. Roughly, we say that our galaxy would be containing about 100 to 400 billion stars are there in the Milky Way galaxy only. So just try to figure it out that out of the 100 to 400 billions, like we don't know the exact numbers of the stars because each and every day new stars are being discovered. So we can't say that 392 or 400, and we can't come to an exact number because still new numbers are being added here. So
Yeah.
there are about 100 to 400 billion stars just in the Milky Way galaxy, and Sun is one of it. So just imagine how big the Milky Way galaxy is. Further, there are so many galaxies. Do you have any idea how many galaxies are there?
Mm, no, sir.
Some estimates says that there are about 100 to 200 billion galaxies in the universe. So just imagine this. So just imagine that there are about 100 to 200 billion galaxies in the universe, right? And I'm saying that in just one
Yeah.
galaxy, for example, we have the example of Milky Way galaxy. Milky Way galaxy. How many stars are there in this? I'm saying about 100 to 400 billion. So just do the maths and try to figure this out. Like just one galaxy has about this many stars. And how many galaxies are there? There are about 100 to 200 billion galaxies. Just imagine the uncountable number of stars that is there in the universe. Okay, now? Anyways, continuing further. Separation of substance. So, which method is used to separate sand from water?
Filtration. Wait. So filtration and sedimentation.
No, think carefully. First of all, it has to be sedimentation. No, after
Yeah, yeah,
sedimentation, decantation is done. Okay.
yeah.
So the appropriate answer is sedimentation. Okay.
Sedimentation.
Next.
What is the process of removing water from a substance called? Removing water from a substance.
Yeah.
This is filtration.
Yeah. This one is filtration. Okay. No? Correct.
Which of the following is a method to separate mixtures based on density? Density is filtration, chromatography, sieving, decantation. Decantation. Um,
Yes. Like let's start
sir,
by canceling out the options.
yeah.
Let's cancel out the options which will not be the answer. Okay. Is
Filtration
filtering?
only.
Okay. It is not.
Sieving is also not
Sieving is also not there. Proceed.
there.
Okay.
Yeah.
Getting the question. Like the question is that which of the following is a method to separate mixture based on density?
Chromatograph.
Hmm? You're saying
Chromatograph.
chromatography.
Yeah.
Okay. See, the thing is that we have different methods which are based upon the density of two materials, right? One of we are going to come back to the question, but let me just give the background. We have learned about centrifugation. Remember
Hmm.
centrifugation. Remember the churning of the milk, right?
Yeah.
Now, how the milk will be churned. So we know that
Yeah.
the fat molecules that are present in the milk that are less denser, so it floats above the milk. Many times, if you
Yeah.
would be when we drink the milk, we might find some yellowish droplets.
Yellowish color.
So
Yeah.
that is actually fat now. So fat being less denser, it floats on top. So via the churning, all those less denser fats will accumulate on top. As we know, oil is less denser. No, oil is less dense.
Okay.
So thereby
It
it
will float
floats.
on water.
Exactly. So that is the case. So centrifugation is one such method. Okay.
Yeah.
Furthermore, we have like for example, a separating funnel also. That is also based on this concept of that two
Yeah.
substances have different densities. Like how oil and water will be separated using a separating funnel, as we have learned about this. So you have a separating funnel like this. Remember, and we have a stopper here, and we have, let's say, two solutions with different densities. Let's say this is water, and let's say oil is floating on it. So both of them are having different densities. That's why they can be separated using a separating funnel. Getting it now? That is one thing. So here the
Yeah.
question is about chromatography. So for chromatography, like you tell me what is the principle of chromatography? As we learned about it, what is the principle of this?
Um.
Hmm? We know that if there is a mixture, for example, a pen ink, it is a mixture of different substances, right now?
Yeah.
And those mixtures will be dissolving, for example, in water at different rate.
Yeah.
Getting it now? They will be dissolving in water in a different rate. So thereby
Yeah.
they can be separated from each other with the help of a chromatograph paper. Getting it now?
Yeah.
So the principle here is that when a mixture would be dissolved in a solution, or when it is applied on a chromatography paper, so based on its solubility, it will be there will be differences in its difference in the way how it is going to spread. That is
Yeah.
one thing. The question here, coming back to the question, it is that which of the following is a method to separate mixture based on density? Okay. Now, when we look at sieving, it is based on the difference in the size, so it is not
Yeah.
correct. When you look at decantation, decantation is basically the pouring of the clear liquid after sedimentation
Yeah.
process is done. Chromatography is also not based on the density. I think there's some error in the question. Okay, now
Yeah.
if the option were like centrifugation or using a separating funnel, then we could have answer that as correct. But I think
Yeah.
there needs to be some correction in the question. Okay, so we are not continuing this. Okay,
So
Halima,
decantation is also not there. So.
decantation is also not there, and chromatography is also not there. Okay, now
Yeah.
so it's none of these. Okay, what is the main purpose of chromatography?
To separate colors in a mixture.
To separate colors in a mixture. Correct. Which technique is best for separating a soluble solid from a liquid?
Soluble solid from a liquid.
Hmm.
Filtration, evaporation, sieving.
It's a soluble
From
solid. Keep this in mind. Hmm.
soluble.
Yeah, meaning that it dissolves in the
Dissolve
liquid.
in yeah.
It does not settle at
Evaporation.
the bottom. Exactly. That is evaporation. Well done. Okay. Like we have example of sugar and salt. Okay. Next.
Yeah. Which of the following is an example of a solid material? Wood.
Undoubtedly, that is wood. Metals are usually good conductors of heat and electricity.
Metals. True.
That is true. Very good.
Name 3 materials that can be classified as insulators.
Hmm. What are
Insulator.
insulators? Insulators क्या होते हैं?
That are good conductor of electricity.
Insulators are bad conductors of electricity. They do not
Oh.
allow the electric current to pass through it. Okay, na?
Third,
Also,
wood,
wood, good, and
plastic,
plastic,
and wood, plastic, and glass.
glass. Okay, and distilled water is also such an example. Okay, distilled water,
Yeah.
which is pure water, which does not have any impurity. Getting it?
Oh,
Remember in the class, in fact, we learned about this. If you have an impure
yeah.
water, it will allow the current to pass through it, but a pure water will not allow current to pass through it. So we have distilled
Distilled water.
distilled water. Okay. Material can be sorted into two main categories. Yep. Materials can be sorted into two main categories.
Two main categories. Shape and size.
Not on that basis. Like let's say based on their hardness, for example. Based on their hardness, how can they be categorized?
Texture.
Oh, soft material and hard material, no? Like that. Okay, no? So hard materials are those materials which we cannot easily which cannot be easily crushed. Getting it? Or which cannot be easily broken. For example, the different kind of metals, iron, copper, etc. Right now, so they are hard materials. Soft materials can be easily compressed. They can be easily deformed, like cotton or a
Like
sponge,
rubber.
like rubber. So you can easily deform it. Like I have a rubber in my hand, I can twist it like this. The shape can be deformed.
Yeah.
Okay, that is the case. So we have soft material and hard material.
And hard material.
Okay, match the material to its category. So these are the materials given here, and do tell me whether do they belong to the first category or second category.
Sir, glass will belong to insulator. Glass
Insulator.
is insulator.
Good. Next.
Plastic is also insulator.
Very good.
Copper is a conductor.
Copper is a conductor.
Rubber is also insulator.
Rubber is again an insulator. Very good. Well done. What is the unit of electric current? By the way, you don't have this chapter, no? Actually, I took these questions for the other students, so you can leave that. Okay. Okay, we did practice some questions. So today let's do one thing. Earlier we had completed the revision of components of it, right, Halima?
Yes, sir.
Today we can do the revision of other chapter, that is separation of substance. Yes.
In the revision paper, I had a doubt.
Okay, the revision paper which we were discussing earlier.
Yeah.
Yeah, go on.
Sir, I had a doubt in the fifth question.
Fifth question.
Yeah.
Okay, just let me open the sheet and then we are going to continue. Okay.
Sir, it's already opened in my.
Okay, you can read the question.
Okay. Sir, fifth question, it says that
Hmm.
which of the following is a xerophyte?
Okay. So what are the options for the xerophyte?
Examples of a xerophyte.
Like
Rose, prickly
continue.
pear, pine and fern.
Rose, pine, and
Fern,
fern, right?
yeah.
And
Prickly pear,
can you pronounce it? Pronounce the spelling.
P-R-I,
P-E-R-I.
P-R-I,
P-R-I.
C-K-L-Y.
C-K-L-Y. Prickly pines, you're saying.
No, pear.
Okay, prickly pears. Okay.
Yeah.
Prickly pears. Okay, first of all, we need to understand what a xerophyte is. Okay, now?
Yeah.
Xerophytes are those plants that usually grow in deserts that can survive in extreme sunlight, like for example, cactus. They can survive even if there's very low amount of water available to them. Getting it now? So these are the plants that are adapted to live in low water conditions. Getting it now? And in extreme heat conditions. We have several examples of this. Like for example, aloe vera is a common example. Getting it?
Yes.
Yeah. Aloe vera is an example. That is one thing. Further, let me just tell you what I have done. These are plants that are well
Sir, can I
adapted.
note it down?
Yeah, sure. Plants that are well adapted to survive in dry conditions. That are well adapted to survive in dry conditions. Okay. Further, they can survive in dry conditions and can withstand withstand heat. Okay, now withstand heat means that it can tolerate the heat. Okay, now now
Yes.
talking about the examples, following are some of the common examples of the xerophyte. Like cactus is an example.
Yeah.
You have the examples like pine is an example.
Yeah.
Prickly pear, that too is an example of this. Getting it
Yes.
up? Aloe vera.
Sir, aloe vera is yeah, aloe vera. Yeah.
Aloe vera is an example. No? Okay. These are some of the examples. But here we have the like rose is given here. Okay, no?
Yeah.
So rose plant, I don't think this is the example of a xerophyte. Okay,
Sir,
no?
because it is already stayed in water. Right? No, it's
Xerophyte,
not.
yeah, 1 minute, just 1 minute. If you were to look at the rose plant, okay, no? So there are some species of the rose plant that I think are adapted. Can you repeat the question? What was the question again?
The question was, uh, which which of these is an example of xerophyte?
Okay, which of these is an example of xerophyte? So the
Yeah.
examples that are of xerophyte will be the pine, prickly pear, okay, no? Prickly pear, pine, and the rose plant. Getting it?
Yeah.
The fern, I don't think fern is an example of this. Getting it? Fern
Yeah.
will not be the correct answer. Okay, so that is the case. So xerophytic plants are the following ones. Got this now?
Sir, saying which of these is an example? They're not saying which of these is not.
Yep. So which of these are the examples? So you have the prickly pear, you have the pine, and the rose. Got this now.
Okay.
Hmm. So these are some of the common examples. Any other question in this?
Sir, can I check?
Yeah, sure.
Um,
Yes, Salima.
sir, no questions.
No
Only
questions.
that.
Okay, okay. See, talking about the fund, only these four are the even options there.
Yeah.
I think there are some funds now that too are zero fighting in nature. There are some funds, some types of funds are zero fighting, meaning that like they too are adapted to survive in the dry conditions. Okay, now. So we have this
Yeah.
some examples of fern also. So I think we should update this one. So fern is also one such example. So all the given options here are now the examples of the zero fighting. Okay, now.
Yes.
So this will be the updated answer. Okay.
Sir, but in the answer key of this, ma'am told that it's only prickly pear.
It's only
Only prickly pear.
prickly pear. No, no. If
Yeah.
you were to look at the zero fights, just let me show the images of this to you. See, if you were to look at the pine, see, not this one by the way, this one actually. See. So as you see here, like this is the pine plant. Okay, now, and pine is an
Yes.
example of this. Okay, I think no pine. This not this one. Pine actually bears the has a kind of needle-like leaves are there in the pine. Okay, give me a minute. I will be showing an image of it to you. Okay, now 1 minute.
Yes.
Yeah. Today, by the way, we'll be continuing with now next chapter, that is separation of substance. Okay, now earlier our discussion was finished with
Yes,
that
sir.
chapter, so we'll be taking up this chapter today. Okay. Okay, I'm going to reshare my screen. Sorry for making you wait.
Exactly.
See, the first kind of plant that you see here, that is a rose plant. Okay, now there are different species of the
Yeah.
rose plant. Some of the species of rose plants are xerophyte. They can survive in dry conditions. Okay, now they can
Yeah.
survive in dry conditions and withstand the heat of this extreme sunlight. Okay, now so we have
Yes.
the example of the rose plant. Okay, the second image here that you see, this is the fern. What is it? It is fern. Getting it now?
Fern. Oh, fern is
1 minute. FERN. Okay, now so some species of ferns are also xerophytic. The third image that you see here, that is pine.
It's a pine.
Okay, now and the fourth one you can guess, that is
Cactus.
prickly pears.
No, prickly pear. Sorry.
Prickly pears. So all four of them are um, examples of xerophytes. Getting it now?
Yes, sir.
That is the case. Okay,
Sir,
now so but the thing here
prickly
is now.
pear is
Mhm.
having some fruit-like things, right?
Exactly. Okay, now you are always saying that the thing is that some species of ferns or some species of roses or some species of pines are xerophytic, but prickly pear, all of them are xerophytic. Getting it now?
Okay.
So that is the case. Okay. So in the chapter separation of substances, we have this is there in your syllabus, no? Separation of substance.
Yes, sir, it is.
Yeah. So we are going to do this chapter today. Okay. Um, so in this chapter, we had learned about various concepts, right? Let us revise those concepts which we have learned. Okay. Okay. In the separation of substance, we did learn about various things. First of all, I would be asking some questions to you from the chapter separation of substances,
Yes.
and then we will continue. Okay, now. So you
Yeah.
tell me what are some of the common methods of separation of substances?
Common method of separation of substances are winnowing,
Okay.
sieving,
Hmm.
handpicking,
Okay.
uh, handpicking,
Yes.
winnowing, sieving, handpicking,
Threshing.
threshing,
Yes. And
filtration,
filtration and sedimentation,
sedimentation, decantation.
decantation,
Yeah.
evaporation,
Yeah.
distillation, isn't it?
This, yeah.
Right. So we have one more. Is there magnetic separation also?
Yes.
Getting it now? So you have different methods of separation. Okay. So further, you tell me that um, like what kind of materials you would be able to separate via the first simple method, that is the hand picking. What is the principle for this method of separation?
Sir, it can be different. It can be basis of different colors,
Hmm. Different color.
and it needs to be like
It could
small
be a
and big,
okay variation in
and
size
yeah, variation in size,
and
and also soft and hard. Also, we can
okay.
do, and soft and hard texture. It is soft and hard, and
Hmm.
um,
Basically you have covered all the principles for it. Okay, now basically if they are different in size, they are different in color, shape, right? Now on that basis you can separate those substances. Okay, further in the chapter we have learned about the pure and impure substances, remember?
pure and yeah,
So what do you understand by a pure substance?
pure sub pure substances are those substances that um
That are made up of only one type of particles, one type of
yeah,
substance, right? Now for
like
example,
distilled water.
yeah, distilled water for example. Very good. Or for example, a piece of iron or copper or salt, right now?
Yeah.
So all these are made up of only one type of substance. Are you getting it now? So they are called as pure substances. So pure
Sir, glass.
substance, yeah, glass, we can take that too. So they are the substances that are made up of only one kind of particles, or they are made up of only one type of atoms and molecules we see.
Yeah.
That is one thing. Further, we learned about the impure substances also. So what do you understand by the impure substances?
They are all mixed together, like all like oxygen.
Air, for example, is a
They are
mixture.
made of one or more atoms.
Yeah. Basically, the thing is that impure
They are
substances,
combined.
exactly. The thing is that the impure substances are the substances that contain more than one type of particles in them. For example,
Yeah.
milk. Why milk is impure? It does not look like impure, but why is it impure? Because it
Sir, because
contains
it contains fat in it.
fat in it, exactly. Okay, now for example, you take the pond water, right? Now water
Mm,
from the pond. So that is
yeah.
again a impure substance because there are so many impurities in it. Getting it?
Yeah.
So what is the impurity here? Like when we talk about impurity, what is impurity? So impurity will be
Which
the,
contains more like different types of particles.
I'm asking
One
about,
or more particles.
no, no, I'm asking about not about the impure substance. I'm asking about impurities. Impurities,
Oh,
Halima. So impurities will be the substances that will make a given substance impure. Getting enough? For
yeah.
example, presence of mud in water makes it impure. So mud is the impurity here. Getting it now? So impurities are the unwanted particles which are present in a given substance and thereby it makes it impure. Okay.
Yes.
Further, we learned about mixtures. So mixtures basically substances which will contain more than one component mixed in any given ratio. That will be called as mixture. That will be called as mixture. So it is made up of two more different substances which are mixed, but they are not chemically combined. They are not chemically combined, meaning
Chemically
that they have not reacted. Like for example, if you were to take two substances, let us say that you take yes,
oil and water.
oil and water. So
Yeah.
they it is a mixture. Further, we see that they have not chemically combined. So what does chemically combination means here? Take for example, you take some acid and base. You put them together, they will be chemically reacting.
Yeah.
You take an
Sir,
iron rod and you put it
yeah.
in the water or in moist air. Okay, no?
Yeah.
So it will be reacting with the water and oxygen, and rust forms on the iron. The iron becomes rusty. So
Yes.
chemical reaction is taking place. It chemically combines with oxygen and water. But
Yeah.
in the case of mixture, like here, you have different substances. 1 minute. And this, as you can see here, is the chemical reaction taking place between these different grains here?
No.
No. So mixture chemical reaction does not take place. They are not chemically combined. That is one thing.
Physically come.
Exactly. And they can be easily separated.
Yeah.
Further, we have two types of mixture. Remember?
Homogeneous and heterogeneous.
How are they different from each other?
Sir, homogeneous mixture are the mixture that are distributed evenly.
Hmm. The components are evenly distributed. So thereby you
Yeah.
can't see them properly. You can't distinguish it. Which one is which
Yeah.
particle? Like for example, if pure air, there is pure air, which does not
Mhm.
have any dust particles floating in the air, if it is pure air,
Yeah.
so will you be able to distinguish between
No.
the component? No, that is the case. Or take for example, alloy, like this bell that is made up of brass. Okay, na? So
Yeah.
brass is an alloy. Brass or
Yeah.
bronze, these are the alloys, and they are made by mixing two
Copper,
different.
steel, and bronze.
Exactly. So brass, bronze, these are alloys. Getting it now?
Yeah.
So alloy is a homogeneous mixture of two or more than two metals. Okay, na? And some non-metals can also be used in it. Okay. Take for
Yes.
example bronze. Bronze is, you might have heard of the term bronze, like bronze medals are awarded
Yeah, yeah.
right now. Okay. Recently, India participated in the Olympics and India won 6 medals. 1 silver and 5 bronze medals were won by India right now.
Yeah.
Okay. By the way, you know about the Olympics now, Olympic Games?
Yes, sir.
Okay. So which country won the maximum gold in Olympics? India won only 6. But you know which country won the maximum gold in Olympics? It's the United States of America. Okay, na? It
Okay.
wins the maximum number of gold
The
every year.
USA and China, right?
USA and China as well. USA, China, these are the countries on the top in winning the gold in
Japan.
Olympics. Japan also, well done. Okay, na? USA, China, in fact, Britain also. Britain,
Yeah.
Australia, these are the countries on the top in terms of winning the gold in Olympics. Anyways, talking about the bronze, I was saying that bronze is made by mixing different kind of metals. Okay, na? Like we can
Yeah.
mix copper, okay, na? Copper with tin. Getting it now? That
Yeah.
is the case with this. So we are mixing two metals in such a manner that
Okay.
we cannot distinguish between which metals have been
We
used.
cannot understand which is what.
Exactly. That is the case. Okay, na?
Yeah.
So hope you are getting it. Okay. Okay.
Sir, and heterogeneous mixtures, we can distribute it evenly, like fruit
We,
salad, chocolate chips,
exactly.
uh, different sizes of books,
Hmm.
color of the clothes.
Exactly. So to make bronze, these two metals are used. One is copper, another one is tin. So once
Tin.
they will be made, it will be looking like this. It will be having a color kind of like this. But will
Yeah.
you be able to tell which one is copper, which one is tin? No,
No.
that is the case. Okay, no? Okay. In the case of heterogeneous, you will be able to distinguish between the components that are present. Okay,
Yeah.
that is the case. Further, we learned about different methods, different ways of separation of substances. So there are several
Yes.
principles for separation of substances. Color, it could be shape, their size, their density,
Yeah.
their solubility in water, etc.
Sizes. Yeah.
Okay, but the question is why separation is important? Why do we need to do separation? So
Sir,
there are. Mhm.
separation is important because uh, uh, it it is important because it will save our time.
Okay, good.
It will not look like a very dirty. It should not look dirty place. Or
Okay, like those are the points which you can add later on. Like if the question is asked, first of all, you have to add the main and important points, like to get the useful substances from a mixture. Like there's
yeah.
a mixture of sand and rice, for example. So which is the useful substance for you? Which is edible? It is rice.
Right.
So we are trying to separate a useful substance from the mixture to get the useful substance from the mixture, right?
Yeah.
Or you can say that to get rid of the impurity, like the sand is an impure thing for the health, it's a harmful substance.
Yeah.
So to get
Yeah.
rid of the harmful component in a mixture, right? Or say
Yes.
you have different things of different, you have a mixture of different things that vary in size. So
Yeah.
you can group those things given in the mixture as per their size. Getting it now?
Yeah.
That is one thing. Okay, for later on, you can say that like to organize the place, to make it look neat and clean, etc. So these are the reasons why separation is done. Okay, okay, now that is the thing. Like to obtain a pure substance from a given mixture, uh, or to obtain useful substance, right? Or for the sake of convenience in studying it also, right? Now, say that you have a mixture of lots of things and you have to study them right now. So it will be difficult if it is not organized. So to study each component separately, we have to separate them. Like say for example, I have a mixture here. Again, let us take the first example, or let us take the example of this one. We can always refer to this example. The simple example, let us say that we have this one. So there are different components in the mixture, and say that you are a food scientist. You are a food scientist. So you have to study about the different grains here. So how will you be able to study them if it is mixed together? You have to separate them to study it
Yeah.
conveniently. That is one thing. Okay. And these are some of the common methods: hand picking, threshing, winnowing, sieving, sedimentation, decantation, filtration, evaporation, and then that is,
Yeah.
and then we have distillation.
This is good.
Let's quickly revisit these things. In the case of hand picking, we would be lifting the unwanted elements and wanted components simply by our hand. Okay.
Yeah.
So the materials that will be differing in size, their size will be different, their color will be different. Okay, no?
Yeah.
So their number will be different. If something is in
Yeah.
large quantity, another one is in less quantity. So it can be separated using the hand picking method.
Yes,
That
sir.
is one thing. In the case of threshing, we have learned that like you have the stalk of the grain.
The beating actually.
Exactly. So you
The
will beat it.
beating the
Mhm.
crops.
Right now. So first, the farmers, what they will be doing after the crop will be harvested, after the crop is mature, once it has been cut, then they will
Yeah.
allow it to dry in the sun. Okay, no?
Yeah.
Okay. Also, we know that if the farmer were to manually pick every grain from the stalk, how much time will be consumed? Too much of time will be
So much.
consumed,
Yeah.
right? So they can't do it with the hand picking method.
Hand picking. Yeah.
Okay. So say if there is a small amount of stock, so they can simply beat it on a hard rock and the grain will fall off.
Yeah.
But the grain is right now covered with the seed coat. Getting it now? Okay.
Yeah.
Further, we can take the help of bullocks also. Bullocks. If there's a
Yeah. Yeah.
large quantity, so we will make the bullocks walk over it and it will be separated. So what is the principle for this? So this method was based on the principle that stalk, okay, na, and the shaft here, the seed coat, they are soft, right now, and we know that seed is harder. Seed is harder now. So thereby, when it is struck on a hard surface, seeds will be separating and it remains unaffected. So the seed here is heavy now. It is hard and heavy.
Yeah.
But this, so when it is struck, it will be separated from the stalk and it will remain unaffected. Okay.
Yeah.
As you can see here, this farmer is doing threshing here.
Yeah.
But we know that in the case of threshing now, the seed coat is not separated. The seed coat is still there. Getting it?
Yeah.
Okay. So further, what the farmer would be doing now, it will go, yeah. Further, what will happen here? Like if the seed coats are still mixed in the grain now, so via the
Yeah.
method of winnowing, it will be separated. Like when the threshing is done, husk or the shaft which is still attached to the grain seeds now, since both of them have a similar size, so we
Yeah.
cannot hand pick the
Use
shaft
hand
from the
picking.
seed. Exactly.
Yeah.
So basically, we'll be using the method of winnowing. Okay. So as you can see here, this lady with the help of the wind is separating the husk from the grain. Husk, which is
Yeah.
lighter particle, it will be blown away to a to this place with the help of wind.
Yeah.
And husk
And
and the grain,
grain is heavier, so it will remain down.
so it will fall down here. Okay, no?
Yeah.
That is one thing. In the case of sieving, we have learned that it will be done based on the size of the objects here. Right now,
Yeah.
for example, sand at construction sites, we will see that how with the help of the large sieves now, the workers would be separating the sand. If there are some unwanted rock particles in this, it will be separated.
Yeah.
Or we can separate the coarse
Floor.
flour.
Floor also. Yeah.
It's not flour, it's flour actually.
Yeah.
Pronounced as flour. Okay. So we can separate that too. Okay. Then we have the magnetic separation. So you have the mixture of sand or iron. So we can
Yeah.
separate the iron because iron is a magnetic object.
Yeah.
Apart from iron, what are the other magnetic objects we have learned about?
Apart from iron,
Hmm.
um, copper.
Not copper, cobalt,
Yeah.
and nickel.
Yeah.
Okay, what are the three magnetic objects? Repeat.
Iron,
Iron,
cobalt and
cobalt, and nickel. Very good. Okay. Furthermore, I told you that in the process of obtaining the iron from its ore, also magnetic separation will be used. So told you that the iron objects that we use now, it is not found in the pure state in the nature. It is always found in the form of a rock, right? So a rock
yes,
that will be having high concentration or high amount of iron in it, that will be called as the iron ore,
yeah,
right? Now, so the different kind of metals, different kind of minerals that we use now, all of them are mined from the earth now. हम earth से
yeah,
mine करते हैं, right? So iron is mined from the earth, aluminum, copper, everything is mined from the earth. Earth provides us with everything, but
yeah,
not in the pure form. वो rock के form में होता है. So
yeah,
it is taken out from the ground, then it is grounded, like it is broken into small pieces. Then it is made
yeah,
to run over the magnetic roller. So magnetic roller like this, these are two giant wheels now, and above this there is a belt which is magnetic. Getting it? So as
yeah,
it will be falling here now, we see that the magnetic particles will fall down here. It remains attached to this, and when it becomes heavy, it will be falling here. But the non-magnetic particles, it will be thrown away to this another container.
yeah.
Understand? Got this
So
now?
it's just a
Mhm.
construct, like it's just about the sir. Which thing is this? Which
This
separation?
this is magnetic separation, no? Iron is a
Okay,
magnetic object, so iron can be extracted from the iron ore. I told you like ore is the rock which will contain a high amount of given mineral. Like
yeah,
there is iron ore, aluminum ore, like that.
yes,
That is one thing. Okay. We
yeah,
did learn about then like separation of water soluble particles. How do we separate those particles that are soluble in water? So for that we have sedimentation, decantation, etc. So first was the process of sedimentation, in which what we have learned in the case of sedimentation, say that you have muddy water. So what you will do that you will allow it to rest for some time. Okay. So whatever will be the insoluble component in it now, it will settle down at the bottom of the glass beaker,
sir.
right? Yes.
Your voice was breaking.
Is it still breaking?
No, sir. Now it is okay.
Okay. Which part have you missed? Right now we were
I
learning
missed
about. Hmm.
about the sedimentation only
We just have
from the
started
start.
this. Okay. Okay.
Yeah,
See, when we have a mixture of this muddy water, so there are some
yeah,
components in this which is heavy, right? Which
yeah,
components say you're heavy here. So those heavy components will settle down after some time when you will leave it undisturbed. Okay.
yeah,
And how it is settling at the bottom, like the force of gravity will be helping. Because of
yeah,
gravity, it settles down, right? Everything comes down towards the earth now, as we know. Everything that goes
yeah.
up, it comes back to the earth. Okay, but it should be in the
Earth's
grav-
gravitational
earth's
force.
gravitational force, exactly. Yeah, it should be within the earth's gravity. That is the case. So this will be used in separating, like for example, grain from dust and soil. Getting it? Or this
Yes, sir.
process will be used in such a manner where the heavier particles will settle down. After the heavier particles have settled down, this mud is called as sediment, and the clear water इसे हम कहते हैं, that is super
Sedimentation. Sediment. Sorry.
supernatant. Okay, now
Yeah,
then the process of separating the supernatant from the mixture, that is called as a decantation. It's the
yeah.
process that is done after sedimentation, which involves removing the pure water along with the impurity. So we take out this pure
Sir,
water, and the impurity will be left here. Yes, Halima.
what is the role in for glass rod?
For this glass rods, we'll be using this glass rod so that the water is not spilled outside of the glass beaker.
Okay.
Okay, no? That is the case. Okay. Furthermore, we can do the decantation for separation of two immiscible liquids also. Like here we had the example of a insoluble
Separated
particle.
color.
1 minute. Like here in this case, there's an insoluble heavy component that is being separated with the separated with the method of decantation. This
Yeah.
insoluble solid component deposited at the bottom. But say if you have both the components of the mixture are liquid, like mixture के दोनों ही components liquid हैं, and they are
Huh.
immiscible. They do not mix into each other, like oil and water. So that can be done using a separating funnel, and that too is an example of decantation. ये भी decantation का ही step है, okay?
Yes.
Okay. Further, we learned about condensation and evaporation. So these things I suppose you already know. Process of conversion of water vapor into from its from vapor state to its liquid state, that is called as condensation.
Yeah.
Okay.
Evaporation is a process that like the example of water and the salt.
Basically, the evaporation of water here will take place here.
Yeah.